All right, so for this example, we've got a series circuit, right? So hopefully if you notice, I like to draw the pathway that charge can go, right? This is the positive end. It's going to go this way. It has to go through that, has to go through that. There's only one pathway, so these are all in series, right? So we have certain rules in series, right? The voltage gets split and shared proportionally. The current is constant in the circuit. And so when I look at these, I don't know some of those things. So the next thing I'm thinking, well, do I know two things about one of those resistors? And hopefully you identify right here, I have one missing piece, and that is I1. And so I can use Ohm's law and say that, well, I1 is going to have to be the voltage of 1 over the resistance of 1. And so I have 6 volts over 3 ohms, and so that current has to be 2 amps through I1. So I know right now I have 2 amps. However, since I'm in series, right, we know that in series, the current is constant. That's a known fact about series. So because I know now what I1 is, I can immediately type in, write in that I have 2 amps everywhere. All right, and now I'm a step ahead. And now look, I have 2 out of the 3 things in these two. All right, so I can use Ohm's law again. V2 is just going to be I2 times R2, which is 2 times 2, which is 4 volts. And so I've now filled in 4 volts here. All right, and I can do the same thing over here. R total is going to be V total over I total. 12 volts over 2 amps. I'm going to get a total resistance of 6 ohms. You guys agree with that? All right, so I know my total resistance is 6 ohms. Well, hopefully right there, now I'm looking here and I'm missing 2 things. I want R3, and now I know the total resistance, and I know 2 of the other resistance, right? Req, or R total, in the way they wrote it, is equal to R1 plus R2 plus R3, and I know everything here. I know I have 6 ohms is the total resistance, R1 is 3 ohms, R2 is 2 ohms, and I'm missing R3. And when I solve for that, I get R3 equal to 1 ohm of resistance. All right, so I can write in 1 ohm. Now I could have gotten that another way. The voltages also add up, right, to 12. Well, I know that my total voltage, all right, V total, has to equal the voltage drop across 1 plus 2 plus V3. And so I have 12 volts has to equal, well, V1 was 6 volts. V2 we calculated to be 4 volts. And so V3 would have to be 2 volts, right? So when I plug in 2 volts here, well, I can use that to calculate R3 if I wanted to go that route. And so R3 would have to be V3 over I3, which is 2 volts over 2 amps. And there again, we get our 1 ohm of resistance. So I have 2 ways to get that value, and this usually happens in circuits, depending on how you go. If you know your rules about voltage and current in a series circuit, you can methodically work your way through and just fill in the gaps. And since V equals IR is a simple equation, if I have 2 pieces of that equation, I can always calculate the third. And so in this problem, you're looking for each individual resistance, voltage, current, and resistance. If you have 2 of them, you can calculate the third, and you can kind of piece your way through and fill in those gaps until you get the thing you want, which in this problem was the resistance through 3. So you should have gotten 1 ohm of resistance.